In Too Fast, Too Furious, we chose a scenario where Brian and Roman use a 20-degree ramp calculated by using landmarks provided in the movie to propel their car upwards and land on a villain's yacht.
The amount of time we counted the whole jump scene to take was 9 seconds. To figure out if this was actually true, we found the vectors and other variables involved.
According to the movie, the speed at which the car approached the ramp was 120 miles per hour. To convert the speed into meters per second, we multiplied 120 by 0.447 meters per second per 1 mile per hour and got 53.64 meters per second. Using this, we multiplied it by the cosine of 20 and the sine of 20 to get the initial velocity in the x direction and the y direction respectively. Our answers were 50.40 meters per second for v naught x and 18.35 meters per second for v naught y.
Since the horizontal velocity of the car remained the same throughout, the acceleration in the x direction is 0 meters per second squared. The vertical acceleration acting on the car is negative 9.8 meters per second squared because of the acceleration due to gravity.
Next, the distance the car traveled in the air before it hit the yacht was computed. We measured the length of the car and how far the yacht was from the ramp as it appeared on the computer screen. We divided 16 centimeters, the distance from the ramp to the yacht, by 2.5 centimeters, the length of the car. It equaled 6.4 car lengths. The car in the scene is a 1969 Chevrolet Camaro, spanning 4.78 meters in length. 4.78 was multiplied by 6.4 to see how far the car traveled in the air. The x variable is 30.56 meters.
To figure out how far the car traveled in the y direction, we measured the car's height and maximum height reached according to the computer screen and got 0.9 centimeters and 4.0 centimeters. 4 was then divided by 0.9 to figure out how many cars it takes to equal the maximum height. 4.4 cars were required. This was multiplied by 1.3 meters, which is the Camaro's actual height, to get 5.72 meters. Since the Camaro was 0.9 centimeters higher than the yacht, where the car landed could be determined by subtracting 1.3 meters from 5.72 meters. We then subtracted another 1.3 meters from 4.42 to get 3.12 meters because we set the axis 1.3 meters above sea level. So the y variable is 3.12 meters.
Using the first kinematic equation, we were able to get a time with the solved variables. If this unrealistic movie scenario were to happen, it would actually only take 0.61 seconds rather than 9 seconds for the car to fly through the air and crash on top of the yacht.
When evaluating this scene realistically, we set x naught and y naught to 0 meters. We used the same velocity components as before, which were 50.40 meters per second for v naught x and vx, and 18.35 meters per second for v naught y. The acceleration in the x direction was 0 meters per second squared. Also, the vertical acceleration acting on the car is negative 9.8 meters per second squared because it is the acceleration due to gravity. Then we solved for the rest of the remaining variables.
First, we solved for the time the scenario should have taken using the first kinematics equation. We used the quadratic equation to get the resulting time 3.81 seconds and negative 0.07 seconds. However, since time cannot be negative, it should have taken the car 3.81 seconds to go off the ramp and land rather than the movie time.
Second, we solved for the distance the car should have realistically traveled in the x direction using the first kinematics equation, x equals x naught plus v naught x t plus 1/2 at squared. With a horizontal speed of 50.40 meters per second and a time of 3.81 seconds, the car should have actually traveled 192.02 meters rather than 30.56 meters as it was shown in the movie.
Therefore, this movie scene is completely inaccurate. In reality, a car traveling at 120 miles per hour should have traveled 192.02 meters and flown way past the yacht and sank in the water, rather than only traveling 30.56 meters and landing perfectly on the villain's boat.
The yacht in the scene was an AB yacht and its top speed was 42.7 knots, which is 21.95 meters per second. With the car traveling 192.02 meters at 53.64 meters per second, the speed of the yacht is irrelevant as it is much slower and the car will travel way past it.